Hello everybody and welcome back. We're going to be discussing section 2.1, section 2.1, linear functions. In chapter 2, which is also called linear functions, we're doing the first two sections of chapter 2. This should be a review from your Algebra 2 days. And those of you who had pre-calculus, this will be at least the third time that you've studied linear functions. So what a definition is. Definition of linear function is, first off, any function that can be that is represented by a line. On a graph. Except for vertical lines. Except for vertical lines, we're going to talk about vertical lines. But if you have a graph and there's a line, that's a linear function. Also, there's another definition. A linear function is one whose average rate of change, which we were just talking about, by the way, its slope is constant. The average rate of change is constant. That's a good definition. Any function whose average rate of change is constant over all intervals, over the whole real number system. The average rate of change remains constant. That's called the slope. Whoops. Definition of slope is the average rate of change of a linear function. Whoops. Rate of change of a linear function or slope. We use M to denote slope. That's M. It's small case letter M. Probably the Greeks, I guess. I don't know why. Is, of course, change in Y over change in X. Slope is defined as change in Y and over change in X, which we were doing this, y2 minus y1 over x2 minus x1. That's what slope is. Change in y's over change in x's. Here we go. Slope is the change in y's over change in x's. Couple more definitions. Intercepts. A constant function doesn't. Every linear function has a y-intercept. Not necessarily an x-intercept. Constant function wouldn't have an x-intercept. But an intercept is y-intercept. There's two kinds. And x-intercept. I'm going to go to the other side. Over here, I think. Y-intercept and x-intercept. A y-intercept is the point where x is 0. So this y-intercept, we'll call it B, by the way, is the point 0, B. B because it's coming. X-intercept, and we'll put it over here, is the point where y is 0. So it would be, say that's where y is 0. So that's A, or 0, excuse me, where y, 0. A, 0. Oof. So those are the intercepts. So now we have all the definitions, and from here, again, I'm hoping all of this is a relative review for you. From here, we write equations of lines, or functions. We'll go from functions to equations. I'm going to erase this board over here, and let's talk about equations of lines. And there's different forms. I guess I'll just list a slope-intercept form. Slope-intercept form looks like y equals mx plus b. By the way, if we're talking functions, I should really make this f at x, because this is pre-calculus. Y equals mx plus b, where m is slope and b is y-intercept. And so if you're just given y equals so y equals mx plus b, that's one kind of equation of a line. And another kind is called point slope form. And it's what you use when you have a point and a slope. By the way, in calculus, you'll be using this quite a bit. Y minus y1 equals m times x minus x1, where you're given one point. The point would be x1, y1. And the slope. You're given the point and the slope, and you put it in there. So in that way, you create an equation of a line. And so that's what the rest of this section is all about, right? Calculating slope, putting in the point slope form, writing the equation. So most of this is going to be examples from here on out. Calculate slope. Given 2 points. I'll use the examples I have. Calculate slope given 3, negative 2, and 8, 1. It says nothing about graphing. It just says calculate the slope. We may as well plot the points just because, we're right here. Negative 3, negative 2, 1, 2, 3, 1, 2, down here. 8, 1, up there. There's the line. And all we want to do is calculate the slope. Slope is change in y's over change in x's. Whoops. Change in the function over the incremental change in the domain. Which in this case, the change in y's. Now, you can subtract from here to here. If one's written on the right and the other's written on the left, I take the right one as this is x, this is y, y2, x2, y2. It doesn't matter which one you use, but I always use this one. 1 minus negative 2, and then 8 minus negative 3. Let's see, 1 minus negative 2 is 1, and 8 minus negative 3 is 11. So the slope of that line is 1/11. And all we're saying is, for every 11 that goes that way, it goes 1. All right, calculate slope. Where are we? 7, oh boy. I'm trying to make these short. Having difficulty, plus I go too fast. Slope intercept, suppose you're given a point and a slope. For example, I'll go from here. For example, 4, 1, slope is 2. Slope is 2. So if we're given this, we're giving a point and a slope, so you want to use point slope form. And so we shove it all in, y minus, there's the y1, m, x minus, there's x1. Now, because of what's going to happen, we want to put this into slope-intercept form. And that's recommended. Just for every line you have, just keep going to slope-intercept form. Y minus 1 equals 2x minus 8. Y equals 2x minus 7. Boom. Slope-intercept form. It's done. We wrote the equation of that line. Given 2 points. Find the slope. Given 2 points, write the equation. Well, in order to 706 negative 1. From a graph. Suppose that's the point 7, 0. This is the point 6, negative 1. And so here's the line. And what we want to do is find the equation of that line. Equation. Well, first off, we need a slope. Slope is, well, change in y's over change in x's. I'm going on the one. Negative 1 minus 0. Whoops. Negative 1 minus 7. And then change in x's, 6 minus 0. Negative 8. Yeah, that's right. It is negative 4/3. There's the slope. The point. Y minus, hey, you could choose either one of these. Y minus 7 equals negative 4/3. X minus 0. By the way, in slope-intercept form, -4/3 x plus 7. One more thing. I'm going to erase here. 6, -1. I want to use this point. We're going to get to the same thing because when you have 2 points, it doesn't matter which one you choose to use point slope form. Once you get the slope. So what I'm saying is I'm going to use 6, -1. Y minus -1 equals -4/3 x minus 6. Wow, now we got to multiply it by a fraction. That's why we chose the one with 0 on, but hey, we can do it. Y plus 1 equals -4/3 x. -4/3 times 6. 8 plus 8. And then subtract 1 from both sides. Y equals -4/3 x plus 7. I think that should do it for the first section. Bye, everybody. See you soon.